I'm trying something new today, a new topic in a new format, and that is React Server Components. Let's go. I'm gonna walk you through the first 3 React Server Components chapters on my interactive course React tutorial. That's chapter 38, Intro to Server Components, Client-Server Boundary, and Async Components. The following 5 chapters will cover React Server Components. RSC is a new feature of React that brings with it a paradigm shift. You don't necessarily need to use React Server Components, however, they open a range of new possibilities for full-stack apps. In short, RSC enables you to run components on the server. Let me save that. Primarily to enhance performance. So performance, we're going to focus on that a lot in the first 2 chapters. It also lets you build a full-stack application using a single code base. In short, RSC enables you to run certain React components on the server. Let's save that. This improves performance, again, by reducing the amount of JavaScript sent to the client, and it also enables full-stack applications in a single React code base. I'm going to add a small comment here. For example, these are my own comments. For example, for my personal website, I can handle the form submission in React without having to write my own separate API. So, what challenges does React Server Components or RSC solve? When building a React app without RSC, which is if you, it says here what we've been doing so far, so if you've been just learning React, which you should always, by the way, learn React separately before you learn RSC, so start with the strong foundations, there's a note about it. So when building a React app without RSC, all the JavaScript you write will need to be sent to the browser. This can slow down your website. While you can use react.lazy to lazy load parts of UI, the code will eventually need to run on the front end, and sometimes that is actually not necessary. However, the React team noticed that some components never need to run on the front end, as they can run entirely on the back end. More on that in a minute. Moreover, it was not possible to create full-stack apps with React without building a separate API, even though you sometimes just need to implement a form that sends an email. That's exactly the note that I just saved over here. As you'll see in the following chapters, it has become easier than ever to run a function on the server directly from your React codebase. And I also mentioned this note here. Learning RSC requires an in-depth knowledge of React. So this is why RSC is only introduced towards the end of the course. That's chapter 58 of an entire course. So if you don't know React already, please make sure to learn React. I have a course on it. That's reacttutorial.app, linked below, or learn it however you want, and only then think about learning RSC. And the same applies for JavaScript. Make sure you know JavaScript before you learn React. For now, let's focus only on the challenge of performance, as this will help you understand the base of RSC before we move to more advanced use cases. I think this is very important, at least with the way I like to teach things. I don't want to dump everything on you, I want to teach you things step by step. And let's just for now assume that RSC is only meant to solve performance. That is not the only use case, but it's a pretty big one, and if we just focus on this, we kind of can better understand some of the important concepts, like the client-server boundary, that we're going to explain in a bit. So, using React Server Components. To use React Server Components, you need to select a framework that supports RSC. The most popular framework at the moment is Next.js. In the future, Vite may support RSC. At the time of recording this video, Vite doesn't support RSC, at least not easily. This might change in the future. So if you want to check the most up-to-date version, maybe check in the comments, or the course will of course be updated. The video will not, I cannot really update the video, of course, and I might actually find some things some mistakes in the course that I will just tell you about them as I go through them. This is the first time I go through it after publishing the content. A distinction needs to be made here. React apps built with Vite or loaded with a script tag do not support React Server Components, and they work as you've learned so far. So any code you write with React, and if you're just publishing it with Vite, a normal Vite app is actually still running on the client. It does not support React Server Components. Only when you're running in a React framework or an environment that supports RSC, then you are actually running in RSC mode. So yeah, however, once you use a React framework such as Next.js, then RSC is enabled by default and things worked actually pretty differently. We will see that soon. This behavior is what we'll explain in the following lessons. For the remaining lessons and chapters of the RSC chapters, so for the following 3 chapters, we assume you are running a React framework that supports RSC, such as Next.js. I'm gonna skip the recap for now, but other recaps will be more important. We have one more lesson before we start the first challenge. So quick reminder, let's go for components in React framework. Quick reminder for this and the remaining lessons and the next 3 chapters, we assume we are running in a React framework that supports RSC. Components in a React framework behave differently because RSC is enabled by default. This means that every component you write runs on the server, unless you explicitly mark it as a client component. This is very important. So what's the behavior of a server component? Let's take a look. Let's assume you've got the following footer component that you're rendering, and we have an export default function footer. We we calculate the year, and then we return a paragraph with all rights reserved, and then we interpolate the year, or we render the year. Since this is a server component, it runs on the server and it generates static HTML. So this is already a big mind shift. This can remind you of SSR, server-side rendering. We'll discuss it in a bit. But instead of sending the whole component to the front end, we are actually just sending the paragraph. And assuming we run this in the year 2025, we get all rights reserved 2025 wrapped in a paragraph. And again, we come back to the performance benefit. Since the component ran on the server and generated static HTML, it saved us from sending the entire component to the front end. Sending the component to the front end costs precious JavaScript kilobytes that need to be sent over the wire, then they need to be parsed and compiled and executed. Instead, RSC sends the compiled HTML directly with zero bundle impact. It adds nothing to your JavaScript bundle. So you might be wondering, if you've worked with server-side rendering, SSR, isn't it the same as SSR? If you've used server-side rendering before, I just said that, you might be wondering whether that's the same as React Server Components. That's a fair question for now, because at first glance they can look very similar, but RSC goes way beyond traditional SSR and unlocks new use cases that SSR alone can't achieve. And I want to add a sidebar. Many people made fun of it that we're going back to the old PHP era, and this is actually true. So it's not adding something revolutionary, but before we had maybe a PHP backend or Java or anything else, and then the front end was separate. This is revolutionary in a way that you can kind of keep everything in JavaScript. It's not necessarily always a good idea, but it makes many use cases easier to achieve. If you haven't worked with SSR, you can just safely skip that. Think of it this way: SSR renders the whole page on the server, while RSC allows individual components to live on the server. Okay, let's take a look at the recap. Server components run on the server by default when running in a React framework. They generate static HTML, which is sent to the client, reducing JavaScript bundle size and improving performance. And while they share similarities with SSR, RSC offers more flexibility by allowing individual components to be server rendered, not just entire pages. Let's add this to our notes. Okay, let's start with the first challenge. So these are the challenge instructions. Rendered string. The code in this challenge doesn't render to the browser. Instead, it uses React DOM servers render to static markup. This is a function you'll probably not use yourself, to render the component on the server and compile the component to HTML. Complete the app component such that it returns the below HTML, replacing X with the current year. So welcome to our site. The current year, the year is X. Make sure to read the compiled HTML to the console, in the console, to help you visualize how a component can be compiled to static HTML. And I already mentioned that we don't really use that. And the import, I'm importing this from esm.sh because this is the only challenge in the whole course that uses this package, so I didn't want to include it and make things slower. So we have this import render to static markup, and we don't really use the browser yet. And then we have the function app. This is a component, and then here we compile the HTML render static markup app. And if I write return paragraph, hello world, we are just gonna get here the paragraph. So we compile this component into into HTML, and that's going to give us hello world. And now I can just copy these two, but of course they will fail because we can only return one element. So we wrap them with a fragment. And already you see why you must know React already, because I'm not going to explain what this is, because these should be your foundations by now if you're working with React. So welcome to our site. The year is X, and then we can say const year equals new date dot get full year, I think. And then we need to use it here in the template. The year is 2025, and that works. I'm not sure if you can hear the sound that comes with it. So that's the first challenge, really getting started and taking it step by step. If you've taken any of my courses, you know I really like to build things step by step. Because now, and if you want to get an overview of where we are, still in the first chapter, you will learn about the limitations, read some errors, very important. I sometimes want to show you the errors, because then when you see the errors, you will not be surprised. You will already have encountered them and understood why they occur. So yeah, server components, limitations. As mentioned in the previous lesson, when using a React framework that supports RSC, all your components run by default on the server. We saw how server components are rendered on the server and the resulting HTML sent to the client to be rendered by the browser. This was the previous challenge. Now, since server components are rendered on the server, they inherently come with a set of limitations. Server components cannot use React hooks like useState, useEffect, or useRef. We're gonna call these client-only hooks. And that's already like a big change. Wait, let's continue. We cannot even attach event listeners. We cannot use onClick and onChange. And again, this is pretty big because we previously used React to be able to use onClick, to be able to use useState and useEffect. Well, not really useEffect, but useState. And now we're suddenly telling you you cannot use them. Well, yeah, you cannot use client-only hooks and event handlers on server components, but you can still use them in client components. We're going to get to that. So yeah, here we haven't mentioned anything yet about client components. That's because we'd like to teach you things step by step. Before we introduce client components, we'd like you to visualize and experience the limitations of server components. So this is exactly what we're going to do in this lesson and in the following two challenges. In the following challenges and in the remaining RSC chapters, you'll be working with a React app running in RSC mode. I'm gonna show you, oh yeah, here. React tutorial simulated RSC mode. So I'm not actually running in RSC mode, but I've developed or hacked around something that is sufficient enough to provide a simulated environment. It doesn't cover all the edge cases of true RSC, but I think it's more than enough to learn RSC interactively. So if you're following along, please don't use React tutorial as the source of truth for RSC, because it's a front end, it's a client-side React course, and the RSC chapters are just optional chapters offered as an extra. So the code isn't actually running on a real server. Some things like browser APIs may still work here, even though they wouldn't in a real project. So for tricky edge cases, please test locally, or you can ask for guidance on Discord or GitHub discussions. You'll also notice that this environment includes React tutorial specific functions, starting with React tutorial, which of course are part of the simulation and help you in mind that you're now running in RSC mode. So once we see React tutorial simulate RSC, it means we are running in RSC mode. And now, is it your first time working with RSC? In that case, we recommend you follow this tutorial step by step, as it introduces concepts gradually, because you might wanna, it's really good to follow locally, but you might want to think like, hey, let me take, for example, the Super M project or a massive project and convert it to RSC. That's going to be a bit too much. Let's do it step by step. So instead of converting an entire app, let's build step by step. Okay. And I think that like only now we start working with the RSC challenges. So let's take a look at the code. We import strict mode. We import create root. We have a function app, this component app, and we're running in RSC mode here. We have React tutorial simulated RSC and the usual create root, and we render app in strict mode. Strict mode doesn't necessarily do anything special here. and we have nothing in the browser. That's because we have an error. We're gonna read it in a second. Start by running the code and reading the error message. Yes. RSC error. OnClick only works in client components. Add the use client directive at the top of the file to use it. We don't want to do that yet. The error message will instruct you to convert the component to a client component. Please don't do that just yet, as we haven't explained it. To pass the test, you must keep the component a server component and remove the onClick handler. So yeah, it's it is a shame, but we have to remove the onClick handler, but that's because this component is running on the server, so it can never run an onClick, at least not in that way. And if you run the test, they are working. If you click on click me, nothing happens, so of course we can also remove this function. I think I must have the same as the official solution. Yeah. Okay, but what's important was to read the error message, and now we're going to show you another error message. Start by running the code and read the error message. We run it, and then use state only works in client components. So same thing, to pass the test, you must keep the component a server component and remove all the use state code and replace the count with 0. So you can just, you can do const count equals 0, that's already enough. Oh, but we must remove the import. This is, by the way, this behavior is also happening in React frameworks. Run it, it's running. I don't know if I have the same answer. No, yeah, you can also just remove everything. I can copy it. Or if I write it one by one, just remove the count. We don't really need a variable because it's not changing. It's not interactive. And that's kind of the goal. We're not going to use server components for interactivity. We're going to see that in a bit, but just to improve performance in the beginning. Okay, what are we up to next? Intro to client components, and we're towards the end of the first chapter, RSC chapter. When using React server components, all components run as server components by default. We already know that. However, you can also write client components. Client components are the components you're already used to from this course, or if you know React, these are the components you've been using all the time. These are the components that run on the client, so in the browser, and support interactivity, of course. OnClick, OnChange, useEffect, useState, useRef. They all work as expected. Everything works as expected in client components because they are just sent to the client. This means they do not run on the server. Instead, they are added to your JavaScript bundle so they can be sent to the client and run by the browser. Since in RSC all clients are, this should be components. I'm gonna flag this. I'll do it later. Since in RSC all components are server components by default, we need to learn about the use client directive. The use client directive. Let's say we've got the following component running in RSC mode. It's a component app with a button that has an onClick that makes a console log. The app component will throw the following error. We just saw that. OnClick only works in client components. Add use client directive at the top of the file to use it. We must add use client at the top of the file to make it a client component. So you add this directive. And please note, this is like not a JavaScript feature. It's not, that's what React shows. It works, but now we're having proliferation of these use client, use no cache, use cache, and it's kind of getting a bit out of hand. These are not JavaScript features. The only JavaScript feature is use strict, but it doesn't really matter here, and it's kind of become a default with the bundlers and script type module. But use client, when used at the top, will convert the current component to a client component. So the code now works as expected and without errors. This particular component is now added to your JavaScript bundle and sent to the client to run on the browser. The use client string is called a directive. It's a special instruction placed at the top of the file and tells the React framework, or whichever project that implements RSC, could be Vite in the future, how to treat this file. By using this directive, you're telling React that this is a client component instead of the default server component. While the above is correct, please keep in mind that we're starting with simplified and basic use cases. That's very true because we're going to develop this later, this definition. There are many nuances that we'll mention in the following chapter. Let's take this as a foundation and we'll build on top of it. For the rest of the lesson, we have some gotchas. The use client directive syntax must be at the very beginning of the file, even before any imports. but you are allowed to have comments, so comments are okay. So it's okay to have comments before that. And you must use either double quotes or single quotes, and you cannot use backticks. So that's the note here. This is okay, backticks are not okay. We're gonna test them out in the following challenge. And you might now be wondering, like, why not mark everything as client components? Well, technically, of course, you can, but you're gonna lose all the benefits of, or pretty much, I think, all the benefits of React Server Components. Because one of the main benefits of React Server Components is that it allows as many components as possible to run on the server. We will come back to this, I think, in the following chapter. Preventing them from being included in your JavaScript bundle, as this greatly improves performance and the UX. So yeah, let's start by practicing and maybe quickly a recap. Since all components are React Server Components by default, you need to explicitly mark a component as a client component. You can create a client component by adding the useClient directive at the top of a file. This directive must be at the very top of the file even before any imports. The only exception is comments. You can use either single quotes or double quotes. Backticks won't work. And marking everything as client components will make you lose most of the benefits of RSC. Okay, let's start with the challenge. Fix RSC error 1. Okay, it seems like there's an error. Let's run it. RSC error, onClick only works in client components. Add the useClient directive at the top of the file to use it in index.jsx. So fix the error by marking this component as a client component. This will allow the event handler to work as expected, as the component is shipped to the client rather than run on the server. Feel free to experiment with both syntaxes. There's no difference beyond this syntax. And once the component is working, try the component in the browser preview tab, so it must be interactive. If I go ahead and remove the onClick here and I run the tests, it says the type of the app component was expected to be server, but is actually client. No, sorry. So it is a client component, but we expected it to be server. So we cannot remove this. We have to mark it as a client component. So we go to the top and we add useClient. And if I run the test, it's going to work. You can use single quotes and it also works. As you already know, if you use backticks, it's not going to work. And then we can go to the following challenge. That's going to be a little bit similar, but instead of using instead of using onClick, we now have useState. I run it and it says useState only works in client components. So we have to go to the top and mark it again as a client component. I forgot to go to the browser tab in the previous one, but we can see it is an interactive one because this component is being sent to the browser, to the front end. Okay, we're done with the first chapter. Nice work. In summary, most React frameworks support RSC, which is kind of a special mode where components run by default on the server. The most significant benefit for now is performance. We only talked about performance, as more components are run on the server and their result is sent to the browser, making the JavaScript bundle smaller. And I'm gonna come back to this and show you another example. However, RSC opens up a lot more than that. So all components are server components by default, as a summary, and you can mark a component as a client component by adding useClient directive at the top of the file. There's more to it, please bear with us. And because in the next chapter, we're gonna look how adding useClient directive at the top of a file affects not only that file, but also its transitive modules, so all the modules it imports. That's the entire chapter recap. Let's add it, because now if I go to my notes, these are all the notes from this chapter. And we already start with the client-server boundary, chapter 59. We have an intro, then we dive deep, and then we see useClient directive versus client components. And of course, we have challenges scattered around. I hope you're enjoying this. You can follow the course yourself as well. Check it out in the description, reacttutorial.app. We learned in the previous chapter that React components are by default server components who are running in a framework that supports RSC. This is a generic recap. Server components are rendered on the server and they don't support interactivity like useState onClick. Since the browser only receives the final HTML output, not the full JS code, they reduce the amount of JavaScript sent to the user, which makes apps faster. We saw that when you need a component to be interactive, we'll have to mark it as a client component by writing useClient at the top of the file. The previous chapter used a single file on purpose, which made things a little bit oversimplified, maybe too much. In this chapter, we'll look at how RSC works in a real project with multiple files and how useClient sets the boundary between client and server components. RSC with multiple files. Let's say we've got a products app with an app component and a products list component. So in the index.js, we have a function app component which renders an h1 products and renders the products component which is imported from the products file. In the products component, we have a useState and we create a static, we start with a fixed set of products for now, and we have products, set products. This is kind of also simplified a bit. Eventually this could be coming from an API, could be coming from somewhere else. And we loop through the products, and for each product we show a button. So button key product ID. And when we click on it, we just say for now, buy product. As you may expect, the code above will fail in RSC mode because products uses onClick and useState. So how do we fix it? By default, all components are server components. You know that already 20 times. But the app component should stay a server component as it doesn't require interactivity. Take a look at this. There's nothing interactive here, so this can stay a server component, which is the default. However, the products must become a client component, otherwise we cannot have useState, we cannot have onClick. So the products component, however, needs interactivity, so we need to mark it as client component by adding useClient at the top of the product.jsx. This indeed solves the issue and the app now runs as expected. However, let's explore what's happening under the hood. And here's where we start really understanding what useClient does. When you add useClient at the top of a file, you're marking that file or module as client code. And in the following lesson, we'll see that it also applies to its transitive dependencies, not only to that file. So adding useClient defines a boundary between client and server code. This is very essential. Remember, by default, components run on the server until React encounters a useClient at some point, and then starts bundling components to be sent to the client. We're keeping this lesson simple again with just 2 files so we can introduce the concept step by step, because in the following lesson we'll explore the impact of useClient when more files or more modules are involved. And I have a visualization here. What happens when we add useClient at the top of the product.jsx to help you visualize the client-server boundary. This is the same code as before, index.jsx, product.jsx. I do want to put these in tabs eventually in the future. And this is our app. We have the app here, server components, and we have the products. Oh, sorry, yeah. The app is a server component and it renders the products, which is a client component because it has the use client over here. So yeah, again, this is just a setting stone, I think we call it, a stepping stone, setting stone, one of the two. We're gonna explain it even more. We're gonna explain it properly actually here in the client server boundary. So let's take a look, practice this. Start by running the code and reading the error message. Okay, useState only works in client components and the problem is in products.jsx. Of course, because we have useState and we also have the onClick. Then fix the code in the most optimized way possible. More on that in the first hint. What is the hint? The most optimized way possible means we shouldn't unnecessarily mark a component as client component because it will be sent to the client, whereas it can run on the server. So I'll show you that incorrectly. If I do useClient over here, the app will run. Buy oranges, buy apples, we can interact with it. But it is not the most efficient optimized way. The app component is server, but is client, but it should have been server. So this must stay server component because all of this code does not need to run on the client. We can run it on the server. Instead, it's only the products component that needs interactivity, and that's why we can place useClient over here. And this is gonna work. We still have interactivity because this products component is running on the client, but the index.js is still running on the server. And React DOM does all the magic of doing the server-side rendering of this or running it on a server, but then leaving a placeholder to kind of stream products in and everything. You don't have to worry about it. Okay, let's go to the client-server boundary. And in these two lessons, we're really going to understand how useClient works. We saw in the previous lesson how we can add useClient to define the client service boundary in an RSC app. However, it was merely a stepping stone in an oversimplified project, as it consisted of only two files, one rendered on the server and the other shipped to the client. What would happen if the products component renders a list of product components? Here's what the code would look like. Products.js, we have useClient to use useState, and then for each product we render a product component. And then in product.js X, we have the handle click and the onClick here. And we have a question for you, or I have a question for you. Do you think the code above will work, or will we get an error saying that product needs to be marked as client component for the onClick to work? So essentially, we mark this as a client component, so we can use useState, that's okay. But we did not mark product.js as a client component, so are we allowed to use onClick over here? This is a bit of a tricky question, and it all has to do with the imports. We import the product component from the product.js X. So let's see. useClient is not only used to make a component, a client component, it's actually used to mark the start of the client bundle. That's pretty big. When you use useClient at the top of a module, you're defining the start of the client bundle, meaning that the current module and its transitive dependencies will be treated as client code. Don't worry about the word transitive for now. We'll explain in a second. What this means is that when you mark products.jsx as a client component, the product component it imports, it is also automatically marked as client component. So here, this is a useClient, and because it imports product, then these two components are automatically converted to client components or running on the client. So yes, the code with product and onClick will work as expected, and we do not get an error. And we don't necessarily need to add a useClient at the top, as it's being imported by products, which marks the start of the client bundle. This is why we said in the previous lesson that useClient introduces a server-client boundary, the separation between what's running on the server and what's running on the client. It separates code that runs on the server. Oh yeah, it's just here. It's like I've written this. I mean, I did. Let me show you a visualization that's gonna really help you also see it visually. This is just the code for the same components. We have the app components running on the server. It's rendering the products component, which has a useClient, and that defines the start of the client component, of the client boundary, which means everything below it, all the imports, all the components it imports are going to be also running on the client. And that's why product does not have useClient, but it's also running on the client. Time to cover some gotchas. What does transitive mean? In transitive dependencies, it means the dependencies of your dependencies. So if index.js imports helpers.js, which in turn imports lib.js, then lib.js is a transitive dependency of index.js. So the imports of your imports, or the dependencies of your dependencies, sorry. Going back to RSC, when you add useClient at the top of a file, you mark the current module and its dependencies and also their dependencies as a client file, as client bundle. What happens if we add useClient at the top of product.jsx? Nothing special happens. Your code continues working as expected. The directive has no effect as it's seen redundant because product is imported from products, which already has useClient. However, we recommend you don't add useClient to the products.jsx. The component already has an onClick handler, so if it ends up being imported from the server, you will get an error in your project at build time. As you can see, you only need to add useClient at the top of the file for the topmost component that must be shipped to the client. And it will take a bit of time to get used to this concept in RSC. Usually I wouldn't recommend you do these 3 chapters in one go, but maybe continue watching that video tomorrow when you finish the chapter. And there's one more thing I don't mention here, and that is we don't want you to add useClient to the product.jsx to kind of keep it flexible, but it's not really for the product.jsx because it already has on-click, so there's no way you can ever run it on the server. But it's more that you don't want to add useClient to all the components that are most likely running on the client, because you will see later, maybe in the 4th or 5th chapter, you can run the same component on the client and on the server as long as it doesn't have interactivity. That depends on how it's imported, but this is too soon, like don't worry about this. And console log is your RSC friend. As I mentioned, it will take a while for you to gain the client server awareness in an RSC app. That's really normal, requires patience. That's also a bit from the design of useClient. It's kind of confusing by design, unfortunately. So we recommend you use console log hello from the component whenever you're not sure. Next.js has a nice feature where they clearly label server console logs with the server tag. So you just do console log products server, and because it's running on the server, you get the server tag. This is of course not supported on React tutorial. Let's go to the first challenge. Please read the hints when you pass the test to understand how to approach this sort of challenges. So start by running the code and reading the error message. Then fix the code. Instead of looking at each component separately, try to think in terms of client-server boundaries. More details in the hint. We can clearly see, okay, a bit too soon. So we have the index, it's kind of the same challenge. We have the app, h1 products, renders products component, we're running in RSC mode. Products, uses useState. And then renders a list of product components, which are imported here. And in product, we have an on-click over here. Okay, what do the hints say? App renders products, which renders product, we know that. By using useClient directive in products.js, we'll be marking the start of the client bundle, which means product will automatically become a client component. And that's why you don't necessarily need to add useClient to the product.jsx. So yeah, that's why this whole challenge can be solved by adding useClient over here. And it's the same challenge as before, as in a lesson, but now this is running on the server, this file. This is running on the client, and it imports product, which means it also must run on the client because it's being imported from this file. So this file also runs on the client. You don't necessarily need to add useClient here, but if you do, it also works. And I don't even test against it because it's not a big deal. So this brings us to this section, to like the combination of everything we've been learning about useClient. The useClient directive versus client component. We saw in the previous lesson how useClient defines the client-server boundary by marking the current component and all of its sensitive dependencies as client components. In this lesson, we'll demonstrate that a component can be run on both the server and the client. Oh yeah. Depending on how it's imported, as long as it doesn't require interactivity. This is really mind-blowing the first time you learn it and was previously completely impossible. Let's add a rating component to our app. This is a rating component. We destructure the props and we read the stars. So this is like reading props.stars. We render a span with this star element or string, and we repeat it for the number of stars. Let's say we get 4 stars. We have 4 full stars. And then this one, which is a star that is not filled, we repeat it 5 minus the stars. So for example, if we have a rating, if we pass the stars of 4, we get 4 full and 1 empty. 3, we get 3 full and 2 empty. 5 minus 2 equals 3, and that's for the empty stars. This component requires no interactivity. And we can import it from the index.js and it will be rendered on the server. So for example, this is the rating of the app. We import rating here, we render it, it's gonna run on the server, and we will only get to the client, we will only get the stars, we don't get the whole component, it just runs on the server. So the index.jsx module is a server component because all components are by default server components, unless they have useClient, which we know that. Since index.jsx module is a server component and it imports rating, which also doesn't have a useClient, then rating gets rendered on the server. Now here's the plot twist. We can render rating inside of product, And as a reminder, product is imported by products, which has use client at the top and marks the beginning of the client bundle. If you're lost, please wait for the visualization below. So this is the product, it has use client, it imports product, and inside of product we now import rating, and we render a rating for each product. And by the way, here we added a rating for each product. The product component is now also rendered on the client. So the same component is rendered on the server and on the client. This really sounds mind-blowing and honestly takes a bit of time before you can get used to the idea of a component running in both places. Before we explain it, let's visualize it. So that's the whole code. And here we have the app running on the server. It imports the rating, which renders on the server. But it also imports products, which defines the use client, a client-server boundary. So from here, all the components that are imported are running on the client. So we have products, which imports product, running on the client, which imports rating, the same component running on the client. So it's not that rating will either run on the client or on the server. It depends on who imports it. And because we import it from server component app, it runs on a server. Because we import it from the client bundle, it will also run on the client. Yeah, that's exactly what I say here. As long as the component doesn't have interactivity and doesn't have use client, it may be evaluated. I think I should make this clearer. And doesn't have use client. It may be evaluated on the server when imported from server code and sent to the client when imported from client code. Now, if the component has use client, then you will not be able to import it from a server component. You will get an error. In conclusion, there's a difference between use client and the concept of a client component. Use client is a directive that marks the current component and all of its dependencies as client components. Not every client component should have use client. Instead, you should look for the topmost component that must be shipped to the client. This allows you to have components that render on the server and on the client, depending on where they're imported from. And you might be saying, this is too confusing. I don't want to run the same component twice. And I get you, but I mentioned this so early on because it's important for you to know that it's not that when you want a component to run on the client, you give it use client. No, it's only, you have to think in terms of boundary. So this is from rating, product, products, and app, which is the topmost component that must be run on the client. That's products, and that's why products will have the use client. And you will see in a later chapter, it's not going to be covered, in the async components, that actually we will be able to make the products component run on the server, so we can actually further reduce the client code. We can ship less components to the client by making more components run on the server. Okay, this is definitely my longest YouTube video ever. We now added the rating component. This component is imported by index.jsx and by product.jsx. At the beginning of the project, everything is a server component, but you must make the usual adjustment to allow for interactivity. And once you do, the rating component ends up being rendered once on the server and once for every product on the client. So the code doesn't work yet because we have use state in products.js, but we also have onClick in product.jsx. Rating doesn't have interactivity. This is again the same challenge so that you can really apply directly what you just learned. So we need, what is the topmost component that needs to run on the client? That's the products component. So we mark it as a client component. And now you see this is, well, first we pass the test. And users rate us 4 stars. And browser products, the oranges have 3 stars, the apples have 5 stars. They're interactive. This is a server component. It imports rating, which runs on the server, but it also imports product, which has the client server boundary. It runs on the client, which imports product and runs on the client, which imports rating, which runs on the client. We end up having this component running twice, once on the client. Sorry, not twice, but in 2 modes, once on the client and once on the server. And if you come here and then you add use client, well, this is not going to work. Rating.jsx is not marked as a client component. It shouldn't be marked as a client component because we will not be able to run it here on the server. So that's why this component has no directive. Movie night. So now let's get another challenge, kind of similar vibe, but something else. We have to think about it. We've got in this challenge a hard-coded set of movies that will remain hard-coded in preparation for the future RSC chapters, where we will fetch the data from the server or on the server. What's the most efficient way to make this app work in a React framework? Check out the hints for more details and check out the solution for a visualization of the render tree. Nice. Let's take a look. The test will check for the most efficient way. Where should the client-server boundary be defined? Let's see. We have over here, can even go full screen. We have an app component that renders H1P and the movies component. The movies component imports the movie component, and it has a hard-coded list, so we don't have use state over here. And for each movie renders a movie component. So there's no interactivity in this component. We can see that. There's also no interactivity in the index.js. In the movie.js, there's also no interactivity. It's nice, I kind of forgot this challenge. I didn't know what to expect. And we import the watchlist component. And the watchlist component, this is where we have interactivity. When you click on add to watchlist, we just add a console log, the title. So let's go back, minimize, and then, yeah, if you add use client here, the app will work, but the test will complain because that's not the most efficient way. And it's also not on the movies because there's no interactivity here. It's also not in the movie, it's only in the watch list. And this is the start of the client bundle, and we have the passing test now. Let me visualize it. And I say the start of the client bundle, but at the same time, it's the only file in the client bundle for now. Maybe later we'll have other ones. But we have here the server component app, which renders the movies also on the server, renders movie also on the server. So all this HTML we get directly from the server to the front end. Sorry, we get the HTML and we send it to the client. Just the HTML, no JavaScript. But watchlist gets shipped as a React component so that it is interactive. So we learned in this chapter that how you can use client to draw the boundary between the client and the server in an RSC app. Adding use client to a module marks the start of the client bundle, meaning the current module and its transitive dependencies are treated as client components. We also learned that the same component can be run on the client and on the server depending how it's imported, and as long as it doesn't have interactivity. Performance benefits. We mentioned in the first two RSC chapters that the biggest improvement is performance gains. Here's an example that illustrates that. We have the index.jsx, which imports a markdown library called markdown.it, and I say approximately 130 kilobytes. We can go to bundlephobia, markdown.it, enter, and we have 136. This is minified. Yeah, this is of course smaller, but this is only over the wire. It's going to be ungzipped, extracted, and then you will end up with 136 kilobytes. So we use a 130 kilobyte library on the front end, or we used to use it on the front end, to just convert some admin message. This is like an H1, hello from RSC, new line. This was rendered on the server. But yeah, so wait, this is actually not a client component. So this 130 kilobytes is actually never making it to the client. Because take a look. We import markdown.it, we import button, we have an admin message in markdown, and this is wrong, I'll fix it soon. And this just shouldn't be here. Const md equals markdown.it, and then HTML equals md.render this message. We parse it server side, and we pass it using the dangerously set inner HTML API to this div element, and this is how you can kind of show an admin message on top of the website. And all of this is running on, sorry, all of this, got too excited. All of this is running on the server. So there's no need to ship the markdown.it because we just parse it server side and we send the resulting HTML. And the button can be interactive here. And this is a button with a capital B, by the way. It takes that's why I render the children here. And this button is interactive and will be shipped to the client. In this example, the index.jsx imports a markdown library that weighs approximately 130 kilobytes. However, since this is a server component, all the processing happens on the backend and the markdown.it library is never shipped to the front end. saving the client bundle 130 kilobytes, really a massive saving. I love web performance, by the way, so that's why 130 kilobytes is really big in web performance. All what the client receives from the index.jsx is the formatted HTML alongside the button component. That is because button.jsx has the useClient directive. In traditional React apps without RSC, you would end up with the entire Markdown library which bloats the client bundle, and it was only just to maybe sometimes show an admin message. Whereas now we only have the bare minimum that requires interactivity, and that is the button component. In the following chapter, we'll learn about async components and how we use them to fetch data on the server. I'm actually gonna stop here. It's the first time I do this. I did not know what to expect. If you end up loving this video, please let me know. I would love to record the next one. I'm just testing out this format. I have no idea if it's gonna work out. Let me know in the comments if you have any questions. Don't forget to check out the course and let me know if I should record the next video, the next chapter, which is about async components, where you can run fetch on the server in React Server Components and pass data to the front end. Thanks so much, and I'll see you in the next one. Ciao!